as many full nodes as they should. They should talk to like hundreds of them because there's no actual big cost in doing that when the main one you're going to be talking to is whoever claims to have the largest chain, and you can easily verify that from them. It's unclear whether SPV clients should get into fee estimation at all. It's unclear how microchannels and such might interact with SPV clients in the future. Bloom filter requests in SPV are kind of broken and busted and allow denial of service attacks and don't do what they claim. It would be really nice to have a private information retrieval based protocol like Repost or something like it that would be more expensive than just directly asking for particular pieces of information, but would in fact give you the privacy that it claimed, unlike the Bloom filters, which don't really. That's a summary of the major thoughts.
All right, thank you very much, Bram. Next up, round of applause, please. Next up, we'll have network propagation. So whoever has been selected to give that, please take the stage. Please propagate forward.
Okay. Yeah, it was a friendly session, pretty large, but we heard from some key voices, and I think that was really, really useful. So there was a lot of discussion about the physical topology of networks and routing and potential for perhaps overlay networks. Obviously, the relay network's one, but it was made very clear that block propagation is, funnily enough, the key focus for miners. And a lot of speculation around what that would look like. Are there better ways of doing it at a physical routing kind of level? So there was some interesting discussion around that. I don't know if there were any major conclusions, except that basically if Bitcoin doesn't do it really, really well, then the miners will end up doing it themselves. So there was kind of a bit of a kick there. We should do better. So we obviously discussed types of compression mechanisms. IBLT had already been covered pretty well, so that was kind of taken as given. But there was some interesting interest in doing weak blocks. Now, weak blocks themselves don't save you anything, except that because they tend to be very, very similar, and the final block tends to be very similar to the last weak block that you produced, it allows you to basically refer to it by reference and say, just like that weak block, only a couple of differences, which could make huge differences to the amount of data you need to propagate. So that's certainly something of interest, and should be something that's fairly easy to implement, unlike IBLT, which presents a whole swathe of issues. So there's certainly some interest in perhaps getting that out sooner. There was also obviously just general cleanups that have been talked about before in the Bitcoin network, which will, networking code, which will just, lift our game a bit there and open some potential to doing smarter things, particularly for like small nodes. And most fascinatingly, I discovered that if you're next to a hydro dam, 1 Bitcoin is equivalent to about 7,000 tons of water. So.
All right, thank you, Rusty. Give a round of applause there. So next, we'd like to hear from Involving Academia. That was led by Joseph Bono and Lalu.
Hi there. So we'll just do a quick joint recap of what we talked about. So we talked a lot about publishing and basically how academics are judged by a criteria that might be a little bit mysterious if you haven't been a PhD student or on the academic career track. So I work in security as an academic, and there's sort of a standard top tier of journals, things like CCS, Usenix, Security. If you've heard of or been to those conferences, that they may be really familiar, maybe you've never heard of them at all. There isn't like a lot of Bitcoin there. There's starting to be a couple Bitcoin papers a year. But for people like me trying to eventually get a job as a professor, there's a lot of pressure to take my best ideas and send it there, impress other computer security people with how clever it is, even though there's not a lot of Bitcoin people there to hear it necessarily. And then there's kind of a whole hierarchy of like second tier conferences, and then the few academic venues that are more specializing in Bitcoin are things like the Bitcoin Workshop, which is attached to Financial Crypto, or Ledger is just starting up as a special thing. And unfortunately, that's not viewed in the same way. So for academics, they don't get nearly as much career credit in some way. And it kind of presents a dilemma because that's a much better way to get your ideas out to the Bitcoin community, but doesn't give you as many career brownie points. So we talked about ways that we could try to address that, ways that we could try to take research that appeared at the sort of top-tier general academic venues, it's in security or crypto, and highlight or extract them at the Bitcoin-specific things, try to get information going down that way. And also some ways that we could try to get all the really cool research that's happening in the Bitcoin space by non-academics who don't have the incentive to write up a really long, detailed paper that's 15 pages in LaTeX and has 100 references and everything else, and get some of those ideas exposed to the general computer security or crypto crowd, get them more interested in Bitcoin, get them to understand more. There's been actually some progress specifically on computer security, where there are more papers happening there, and we've had more survey papers that try to highlight what interesting problems are. We thought that was one thing we could try to do better, is to try to write more about what the open problems are that academics could go tackle and pose them in a good way to make sure that academics are solving the right problem, which actually could help them, because then they can point in the research paper and say, this isn't just a problem I made up. Academics are prone to doing that, but they can say this is a real problem that was identified by the community. So that would be neat. And then we also just talked about, to the extent that we've sort of colonized computer security conferences and said, Bitcoin's a really great thing for you to throw your experience and your brain power at. What are the other academic fields we could try to do the same thing with? So we all sort of agreed it'd be great if more people who are experts on game theory, economics, law, were looking at Bitcoin more. So maybe we can repeat some of the things we've done in security in those fields.
Yeah. And then also we talked about kind of the educational gap within Bitcoin developers and also academia, that maybe we can start to consolidate some of these previous work that's been on Bitcoin Talk, but buried under a bunch of spam posts or on IRC or something like that. Additionally, to have maybe some sort of repository for educators to create things like MOOCs and Coursera off of, that could be kind of Khan Academy style. Okay, this is how IBLTs work. Here's kind of a P set or a problem lab that you implement it yourself, and then you have the actual resources, but then you can also have people implementing it and learning it more. Then additionally, we thought that to do more outreach to undergraduates, so to have things like clubs where you discuss Bitcoin, or to discuss what's going on in the industry, and to have more courses in the undergraduate development also. And I think, was that everything?
Yeah, I'm trying. Did we miss any of our action items? I think the only other thing we said was funding. So if the best way to convince academics to work on your problem is if you can convince the funding bodies to do it, because if academics get grants, then that's great, and then they'll write a lot of papers and have grad students work on it. So that's a high leverage target to pitch and sing the praises of Bitcoin to academic funding bodies like NSF, who is funding some Bitcoin stuff, which is great, but other academic funding bodies, if we can reach out to them, then that will trickle down to academics.
Yeah, and then for things like Ledger to have certain best paper awards, so academics are incentivized to contribute to these journals where they can have something to point at for their resume to bolster it. Yeah. Thank you.
All right, thanks guys. Really important work for the future health of our community. Next, let's hear from Trustless UX and Human Crypto Interaction, the other HCI.
Hello. So I guess we first off started fundamentally questioning the term trustlessness, and kind of tended towards preferring terms in terms of talking to users, terms like vulnerability and dependency, just to make things a little more clear. And we also questioned a lot about whether users care about trustlessness and security, and how, to sort of change that mindset. And it ends up that a lot of the situations where people are going to, just basic users are going to appreciate the security that Bitcoin brings and decentralized systems bring, is the centralized systems failing and seeing the examples of the trusted systems just not working. So it really fundamentally has to come down to a mindset perspective shift where users are appreciating the security that the technologies that we're presenting are bringing to them. So yeah, and from that, it's you can sort of start thinking about security being the default option, but it kind of goes back to if given the option to have a quicker transaction or something like that, are users just going to sacrifice their security for something that's faster for them when it's making them more vulnerable? And also, in general, how much to tell the user about the cryptography, about the security. Again, going back to how much to just relay to them and how much they even care about that. And also, whether we're even talking about users or if we're trying to pitch this stuff to developers, and the developers, since the developers are the one implementing these things, and whether there needs to be a more concrete relationship between designers and developers in these sorts of software. And we also touched on creating positive feedback loops for user-friendly software and funding those software. So currently there's kind of an incentive to centralize your own application if users are if you're going to be able to get more funding because users are more dependent on you. So kind of thinking about ways to incentivize funding in a more distributed manner. And we also talked about what is the UX problem, because it's different for different people in different situations. And in terms of people having internet access, or, you know, is it really a problem that we need to use cash for buying a coffee? Or so where are the actual pain points that we should be focusing on right now, and then maybe expand on to user friendliness to the less important things later on. Yeah, I guess that's basically it. So thanks.
All right, thank you very much, Paige. Next up, we will hear about threat models and boogeymen. So will someone from that group please come up to share some of their discussion? Will Peter Todd please come up to share some of that discussion? Or Andrew? All right, let's have Andrew up.
Seriously, is anyone from the group who has the notes here? Cool. All right. So I will just make it up. So we talked about, I guess, various threat models against Bitcoin. We talked about threat models, I guess, threats to Bitcoin from other systems, and also threats to other systems from Bitcoin. So we talked about, for example, what did we talk about? What was it? Oh, consensus, fungibility. Consensus, fungibility, yep. Is this our board? There you go. All right, look at this. All right, can you flip it over? The previous page. Previous page. Oh. You gonna take over?
No, you can do it. No. You want to do it? You want me to do it?
I'm happy either way. I mean, I'm already here.
You can have two people go.
Cool. All right.
Work together.
There we go. We work together.
Oh my God. How am I? Go ahead.
Okay.
You can start.
All right. So we were able to categorize I guess, various threat models against Bitcoin into these. I think we had 3 main areas, which are consensus, fungibility, and selective rule enforcement. So in particular, we were worried about the threats towards Bitcoin from miners, I guess, because I guess in some sense, miners are the only part of Bitcoin that I guess involve a human element of trust. Everything else is mathematically verified. So we worried about, well, if miners can somehow collude or become centralized, or if there's any pressures towards centralization for them, what are the risks? So one of them is that miners can cause consensus failure, okay? And they might be coerced into doing this, for example, if there was political or other pressure on them to reverse transactions. Then you might have a situation in which miners are incentivized or forced to be rewriting the blockchain. And then there's a risk of either consensus failure, if there's multiple versions of the blockchain out there, or I mean, maybe different miners are enforcing different rules just based on the legal regime that they're in. Secondly, we talked about fungibility. And this is related in the sense that if miners are looking at the transactions that they are mining, then there is a risk that they will consider some coins to be worth more than others, depending on where they've come from, depending on their history, I guess depending on where they're going. So you might have miners who are trying to track coins for like anti-money laundering purposes or something like that. And the result is that I guess some coins are worth more than others. And this is a very grave risk to Bitcoin, because technically all the coins should be worth the same amount. The goal of Bitcoin is that all the coins are worth the same amount, and we don't have this whole like patchwork of legal infrastructure that everyone needs to keep track of to have any idea of what their coins are worth.
Well, we also discussed basically within the consensus, there's also media and how it's being perceived. So a lot of Bitcoin does have to do with, some of it has to do with price, and a lot of it has to do with perception. And we also discussed that as a potential boogeyman, that the right information needs to be out there and before everyone starts jumping to conclusion, which was how Bitcoin XT got brought up in the conversation, and how that became a little divisive. So that is another major threat, is information, how it spreads, and that is something that does worry some people. And then we did attempt to break down monopolies. There's different type of monopolies within the space. Mining was one of them. Yeah. Also the use of coins and how there's only a few processors. So basically there needs to be a way to incentivize a more distributed use on, to avoid monopolies from every single level.
Yep, that's right. And then I guess returning specifically to miner monopolies, because that was sort of what we spent the majority of time on. Our final concern was, I guess, selective rule enforcement. And this, I mean, everything, this specifically we were able to break down into external and internal sort of rule enforcement. So an example of an external rule enforcement would be something like anti-money laundering legislation, where miners in certain areas are simply not allowed to be mining certain transactions. So they wind up sort of soft forking in extra validation rules that the rest of the network doesn't agree with. And then they have sort of taken control of the network in that sense. Perhaps more insidious is internal selective rule enforcement. And this would be something where miners could start imposing, I guess, rules that benefit them. They might like start demanding ridiculous fees or something. Do we have some other examples of that?
Yeah, we didn't go into specific examples, even though we tried bringing them up. We were kind of keeping it a very high level, so it was hard. So the one interesting takeaway from the end of the discussion was, if the threat can actually just end Bitcoin, should it be just considered a threat, or is it considered a complete failure? And so that was an interesting thing at the end. Where do you draw a line that it's a threat to Bitcoin's future versus, well, if it just annihilates everything, is it really a threat? Then Bitcoin just fails. So I thought that was an interesting thing. I actually think that everything should be considered as a threat, and if something can be that disruptive, then it should be a major point of discussion and something to be considered.
Yeah, and I guess we did spend a while talking about what kind of threats? Do we want to be modeling threats that are so large we potentially can't deal with them? Do we? I mean, we had a long, I'm not sure that we landed on a conclusion.
Because this was actually a bit of a difficult discussion, because you can put everything into selective rule enforcement. And So a lot of things bleed into another as, well, threats to Bitcoin are changes to the protocol as a threat to Bitcoin from different directions. So everything kind of stems from there. So you really have to break down the problem because you have one threat that can lead to 8 different things that may be a threat. So it was actually not an easy discussion to have because where do you start? If you've made a change to a protocol that may be interpreted in different ways, well, now what? Now different parts become different threats. So it's really, it's hard because everything is dependent on each other. Yes, monopoly is a threat, but there could be other things that lead to the monopoly. So where do you start with each other? I don't know if it's even hard to explain it. So I hope everybody gets the message that this is really a hard thing to conceptualize.
Yeah, that's about as concise as we can make it, I think. So I think we should end it there.
Yeah.
Thank you
Thanks.
very much.
Yeah, thanks.
Thank you. All right, so next up we're going to hear, thanks guys for that. Next we're going to hear about testing and simulation methods. So if someone from that group could take the stage. All right.
Okay, so let's see. Our charter was to think about testing and simulation and testing techniques. And the motivation for this work is very, very, very clear. We've all seen the acrimonious battles over the block size. We've seen how vitriolic these discussions can get. We've also seen distributed systems often get designed by sort of a gut feel. You know, how many neighbor slots should a peer have? 32, 64, I don't really know. And typically, in many contexts, these numbers don't really matter. Any number will do. But in the Bitcoin context, these decisions actually have real monetary consequences. So the big driving point for our discussion was, indeed, science compels us to hold these discussions to a higher standard, to reason quantitatively. And we need better tools for that quantitative reasoning. So now so of course, that is not to say that we can quantitatively solve every problem. There will always be political decisions to make, but those political decisions should be informed by actual measurements and not just by gut feelings and sort of appeals to emotion in emails and so forth. So then the discussion comes down to, well, okay, what do you want to measure and how do you inform those measurements with data? And what data should you collect from the network? As you can imagine, the Bitcoin network is actually quite understudied given what it does. And so we spent a fair bit of time thinking about what sorts of data to collect from the network, and I just want to go through this because I think it's going to resonate with many of you, because these are really things that people might want to know. One of the main things, of course, that a lot of us want to know is nodes configurations. How do people configure their nodes? And it was, at least around our table, it seemed like a lot of people were willing to share this. Peer lists. The topology of the network is a very interesting structure. Just like the internet is a living organism that's sort of emergent and has some emergent behavior, the Bitcoin overlay is a similarly emergent network, and its properties are exciting and interesting and understudied. Bandwidth between peers, we'd love to know this because it is a critical component of any measurement. Latencies between peers. The orphan rate is something that is really critical. You might go to blockchain.info and you might see a number there that's reported as the orphan rate. That is not the real orphan rate. The orphans are dying and getting pruned inside the network, and you really need to know this because the orphan rate represents the amount of wasted effort, and it's critical for the miners and other people who are doing service to the network. Mempool size, the blockchain state. Are we having a fork? Are we having a divergence? How do we actually detect this? Transaction arrivals, where do they come from? Where do they go? What happens to them? Timestamped data. So as you might imagine, that a lot of this data is not timestamped. And of course, there's a lot of exciting data at the blockchain level, which is where are the USTXOs going? What is the shape of the transaction graph? How is it evolving? Is there some hot action in some portion of the economic space? So that's a level up from the network level. So this is sort of the first level of sort of data to collect. Then the next question is, okay, that's fine and good. Everything that you just said actually has some privacy implications. How do you collect this data? And indeed, there is a very real worry that attackers might use this data to actually launch attacks. And they can actually gauge the success of their own attacks and maybe adapt on the fly and so forth. and raw transaction logs, if you were to make them available, people could actually triangulate the source of transactions and find out where users are in the network, perhaps. So there are real concerns. But actually, after a little bit of discussion, it is actually possible to overcome some of these. For example, one could share one's own node configuration, which this is data that I think is incredibly specific to me, and I wouldn't give this out with my name attached to it, but I would give this out under a pseudonym, right? As long as that configuration data is not attached to an IP address, I'm at least personally willing to share it, and I posit to you, or I hope that some of you will also consider sharing your data in some anonymized form. Another thing that was mentioned was an idea to snapshot the network, say something really critical like the topology. This is very sensitive. You don't want to make this available in real time, but snapshot it and reveal it 6 months after the fact. That would be incredibly useful to researchers everywhere, and it would inform a lot of data and a lot of design decisions. The next discussion was perhaps a public repository to which people can contribute their information, their data that they've collected. So we talked a little bit about how to incentivize the miners and pools to generate and share their own data. And then, of course, we spent a little bit of time about how do you make sure that people don't game this? How do you incentivize people to report legitimate data? So there's some discussion about how many locations do you need the beacons at and so forth. The next big discussion that we spent a fair bit of time on was what to study. So suppose you collect all this. What do you do with it? And again, I'll go through this list kind of quickly, but clearly this would be incredibly valuable when we look at the impact of proposed protocol changes. Things like reaction to changes in transaction fees, time-varying behavior of users. So how does the Bitcoin price impact network behavior? And maybe more lucratively, can you tell the Bitcoin what the Bitcoin price is going to be from network behavior? Probably not for long, but maybe you could get some edge on that. So orphan rates, where are they going? This is important for a lot of reasons. Anomaly and attack detection is also very important. So this data not only informs simulations, emulations, and sort of protocol decisions, the offline analysis, but it's also useful potentially for online attack detection. Where are the DDoS attacks coming? What's happening? Is there a selfish miner or whatever else inside the network? Being able to quantify normal behavior versus bad behavior would be very useful for miners, of course. And so miners are very sensitive to things in the network, and the network is constantly changing and shifting. And a very normal question is, hey, are you seeing what I'm seeing? And these are currently accomplished through informal channels, and it would be much better to have sort of better supported channels for this. Simulate what the network will look like under high load. What happens when we have 1 billion users? We have to really aim high here. Maybe not too high because that might really torque us, but that's the sort of the thing that we need to keep our eye on. Feasibility of different protocol changes, the centralization pressures, what's going on there, and economic simulation are all topics that came up. We talked a little bit about the impact of collecting data. Can people misuse this information, and how do you restrict it? Do you restrict it to a closed set? Do you make it public? And the similarities to internet measurement also came up. So as you know, on the internet, people do this stuff all the time. They often have to resort to really crazy hacks. Like, so if you were to look at the King technique for collecting information from DNS, it's really a terrible hack. And it would be much better to support the measurement that people want to perform than to force them to do something that actually puts extra load on the network. In addition, on the internet, network operators willingly pool their data. That's nice if you can trust what they're putting in. But the ideal here is probably building in some measurements into the protocol implementation itself. So we talked finally about a couple of innovative ways of collecting information. Building a geographically distributed testnet came up. It's also part of a couple of BIP proposals. Tracer transactions came up. So there's an opt-in technique. I'm throwing in a transaction. I'd like to trace where it goes. This is, as you will remember, that the IP protocol has options for this kind of measurement. And then the discussion also mentioned a Bitcoin measurement body, kind of like the IETF IRG, so the IETF Internet Research Group. So then finally we talked about how to identify patterns of activity and how to get at off-blockchain activity. So not only is there stuff happening in the Bitcoin world under our own sort of area of expertise, but there's also stuff happening off the chain, and it could move onto the chain, or it could just, or stuff on the chain could move off as well, and it would be good to be able to get a handle on this information. So in closing, I think our group would very much like to urge the core developers to keep measurement in mind as the protocol evolves. The natural tendency for most systems is to close information sources and to restrict what's going on. Just like in the Nutella version 1 versus version 2, the ability to crawl the network disappeared. And that's a very natural tendency. But this is a space where the protocols are under-researched and need to, and the sort of the next level of changes that will have to be applied to the protocol need to be well informed, and we can't be well informed without data. So I hope that we'll keep that in mind. Thank you.
Hey, thank you very much. So this brings us to the middle of all of the summaries. So just as a quick exercise, I'm no Tarek, but just like do a quick stretch, get up, put your arms around, do what you got to do. Well, we have someone from mathematical modeling and spherical cows come up to talk. So get a quick stretch in. And I guess we've got a gymnastic performance. Hey, save it for the rump session.
So we were talking about types of models. So there's the well-known ones like doing simulations, potentially down to emulating your whole code base and everything on multiple peers. And differential equations and simple pencil and paper. One that was brought up, which I really need to read more up on, is mobile process calculus, which you can find out about by searching for PyCalculus, which is a very powerful tool and apparently not all that difficult to learn to do analysis of concurrent process things like Bitcoin. We talked about models, which there are, like there's some stuff about mining incentives. There's a unfortunate lack of any modeling of whether peer selection algorithms result in network segmentation or not. They seem not to, cross fingers. Higher level models are easier if you make simplifying assumptions, which you can sometimes do, paradoxically. Bitcoin is a little hard to analyze, partially just because it's a big monolithic protocol, and even if you clean up the code base by making it more modularized, fundamentally the protocol as a whole is a big interconnected thing with multiple parts that can't be teased out from each other just by its nature. And proofs of stake are yet even more big and complicated and hard to analyze, and all of them have the retroactive go back to the point where you had 50% problem. And those were the main points that we brought up.
All right, thanks, Bram. Next up, can we have someone from Miner Developer Relations come up and share some insight? All right, Matt's on his way.
Hey, so for those of you who weren't there, you missed a great session. So the session primarily focused on how can we improve conversation between miners and developers, which means the only people who came were miners and a few developers, which was very useful. We stayed mostly on topic for the first half. For the first half, we focused largely on dealing with immediate alerts. So your crap is broken, something needs to be done right now. How do we make sure that these kinds of messages can get out quickly and get out to the right people and come from the right people? So we focused, we had a lot of discussion around access control. So who is allowed to send messages directly to mining operators, mining pool operators, and how do we kind of filter that list? And then we had a much longer discussion about kind of what kind of mechanisms and how should these kind of messages look. We talked about Bitcoin's existing alert system and whether or not miners use that today. We talked about building similar things, and we talked about kind of how existing miners have their network designed and in which points in their network we can inject messages that will get to them very quickly. We then moved on to focus more generally about kind of maintaining good working relationships between miners and developers. How do we have good conversations on a regular basis, and how do we have like non-emergency announcements? So how do we have, there's mailing lists for this already, but people don't use them. How can we get people to use them? How can we get people to just talk more about like, hey, new version of Bitcoin Core, you should check out this and this feature, which is particularly relevant for miners, or miners should be aware of XYZ. We then got to the last quarter and got slightly distracted and ended up discussing kind of how why we're in Montreal at all, and why, like, what the block size issues are, and why we're even having these discussions. And this did fit into the topic in that it's important that we have these discussions between miners and developers, because there has not been significant discussion between miners and developers about these issues. So we had kind of a relatively brief discussion about exactly why the block size is still a contentious debate, and why we are in Montreal, and kind of what everyone should be trying to take out from Montreal. That was about it. Thanks.
All right, thanks, Matt. Sounds like a really great session. Next up, let's hear from scalability and hosted infrastructure. Someone wants to come up to represent that group. All right.
All right, so scalability and hosted infrastructure. We were very well represented by Bitcoin. Once my computer just shut off, I'll have to do this from memory. By Bitcoin infrastructure companies. So we had, I won't give the names because that's against the rules, but we had a good number of sort of the number of Bitcoins that are hosted in wallets and transacted, as well as like API calls, stuff like that. So some major takeaways were people of this group, people universally agreed in increasing the block size, which is pretty interesting to me. That's a hard fork of Bitcoin, so it's kind of interesting that this group, anyway, agreed to hard fork Bitcoin. We made one, let's see, there's an interesting point about, it's not just about changing the block size, it's about proving to the world that somehow Bitcoin can govern itself so that people don't have to be afraid that when critical issues arise, we can resolve this somehow, whoever that is. Other interesting points, let's see, we talked about things like the difficulty that the stress test has caused wallets right now. So people are, the wallets are like unsure how to calculate fees. So some people talked about, looking at the code that's in Bitcoin Core, because a lot of work has gone into the Bitcoin Core code, calculating fees correctly, or correctly, again, whatever that means. But so a lot of the wallets have had problems calculating fees. Another really interesting thing to me was that a number of infrastructure companies don't run Bitcoin Core. They run completely different implementations of Bitcoin. They don't run Bitcoin XT. They run other implementations. So I thought that was very interesting. So Bitcoin Core has a little bit less influence than I realized. So those are the major points. Anyway, my computer shut off. If the other guys want to add any points before I exit the stage. That was most of the points. So in a nutshell, I think the most interesting thing was infrastructure companies agreed to increase the block size. So that's my most important takeaway. Yeah, so there were the stress test caused major costs to the network. Do you mean to the companies or to the wall of companies? Yeah. Sure, yeah. That's a great point. So, you know, the stress test, look, people have to dedicate engineers to this problem, right? I mean, there have to be people like just worrying about this. All of a sudden, our customers are not being served because of this stress test. So we have to figure out, you know, okay, what transactions aren't going through. You know, what happens when your customers want to send money and they can't send money to an exchange because, you know, the transaction's held up for a week. So then the customers go directly to the companies. They don't, you know, complain to the Bitcoin protocol or something. So that's a pretty big noticeable cost to the infrastructure companies. That's a really important point that did come up.
Thank you. I just want to remind everyone that agreeing on something is not a decision, just to clarify in that sense, but it represents that, you know, people you know, have a similar alignment of incentives, but maybe they don't agree on exactly how to do so. So next up, let's have someone from Pathway to Adopting Better Cryptography come and share their results.
Okay, I've got notes for this one. So. All right, so we talked about pathways to adopting better crypto. So for the most part, we talked about, I guess, new cryptography that could be used in Bitcoin for better scaling properties. So as far as pathways to get there, we sort of decided most of this stuff we can sort of soft fork in kind of an unexciting way. So we didn't worry too much about the specific pathways. We just thought, well, where can we improve scaling and how can we do it? So the first thing we talked about was in looking at digital signature validation, because that's right now a huge part of validating blocks. It's a huge part of the initial block download. And it's also something that we can sort of work on concretely. And we have been working on concretely in Bitcoin Core. So we talked, I guess, about some boring algebraic improvements. And then we talked about, well, suppose we could replace the ECDSA signature algorithm with EC Schnorr. So this is simply, it's a drop-in replacement. It's functionally identical to ECDSA, but the algebra behind it does not involve any division, which enables a whole bunch of nice new things. A critical one is that it's possible to do n of n multisig. So a multi-signature in which all parties are required to sign. Right now in Bitcoin Core, to create such a thing, you need to create a script that's sort of large. If you want, I guess, 10 people to sign, you need 10 times the script size. With EC Schnorr, it's possible to do this in the same size, like a 1 of 1, a standard script, a standard single signer signature, looks the same as a 10 of 10 signer signature. And then we can extend this a little bit. We can extend this from like n of n to n of n, where there are different values, so like 3 of 5 or 5 of 10 or something. And the way we do this is in kind of a cheap way. We sort of reduce it to n of n. Like if I wanted to do a 5 of 10 multi-signature, I would think, well, I've got these 10 people, so I've got 5 choose 10 sort of different sets of 5 people who might sign. So I just require a 5 of 5 signature from one of those 5 choose 10 possibilities, and I publish a public key corresponding to each of those 5 choose 10 possibilities. And now that sounds very large. I don't know what 5 choose 10 is off the top of my head, but it's big. But we can get a ton of space savings by putting all of the different possibilities in a Merkle tree and then only revealing sort of the one that actually gets used in the signature itself. So the result is sort of like very large multi-signatures, or I should say very expressive multi-signatures whose size is only logarithmic, I guess, in the number of possibilities, which is a big improvement over today's like op-check multisig using ECDSA. Then an extension of that, well, before I continue, let me just say one more thing about Schnorr signatures, which is that they allow batch validation. So we had some ideas where if it was possible to change Bitcoin script in a slight way so that check-sigs were not allowed to fail, so we basically only have check-sig verify as a simplified version of this, then what we can do is we can run through all the script validations for a block, assuming that all of the check-sigs succeed and make sure that all the transactions succeed. So just first off, we make sure the scripts are actually sort of satisfied, assuming the signatures are okay. Then we take every one of the signatures in the block and we validate them all in one shot. And with EC Schnorr, unlike ECDSA, it's possible to combine a bunch of signatures algebraically and then do basically a single signature validation. And by doing that, we get roughly a 50% speed up with the code that we have, and we think we can improve this. You get a 50% speed up versus individually verifying all the signatures. So that's all was just some fairly simple algebraic tricks. Expanding this idea of Merkle trees, we said, well, what if instead of just having different branches for possible multi-sig combinations, what if we extended this idea to the whole script? So now where you might have like an if statement, or a variety of options, rather than having an if statement explicitly in the script, you basically take all the different pathways of execution for the script and you put those into their own Merkle tree. So now, rather than publishing an entire script and then having a signature where when you evaluate it, you sort of only use parts of the script and the rest is just sort of hanging off, you now publish the script pub key as just a Merkle root of your script, and the signature reveals only the pathway that's actually taken. So this gives you some scalability benefits, obviously, because you're no longer revealing the entire script, and there's potentially some very big benefits. So there's a lot of protocols where sort of the standard script execution is very narrow and efficient, and then there's all these sort of fail-safes. You say, well, if one party drops out and this lock time expires, then we have to do this complicated dance to revert everything to the way it was or whatever. The goal is that if these bad events don't happen, you only reveal the nice case, which is very simple. So you can have very complicated sort of recovery scripts where the blockchain doesn't have to bear the brunt of all the complexity of having this rollback opportunities. And then I think I'm running out of time, but we talked briefly about a few things. We talked about like quantum resistant cryptography using, say, like Lamport signatures rather than ECDSA, which would be a huge size hit of like, I don't know, the order of like 100 or a couple hundred times size increase in the size of our signatures. But potentially faster verification, assuming we had SNARKs, which is, I guess, compact verifiable computing, which we've talked about, I think, briefly in some of the earlier talks. This is a very pie-in-the-sky idea where we could basically eliminate pretty much all of the blockchain data and just sort of prove that, and just provide proof that it's all correct. And in that case, actually, it turns out these Lamport signatures, these giant hash-based signatures, would actually be faster to produce proofs for, as opposed to ECDSA. So it's this weird situation where normally Lamport signatures are a very bad idea as far as scalability is concerned. But if we had other magic crypto, then suddenly they're a good idea again. And that's, I think that's pretty much where we landed. We talked also about UTXO commitments in blocks and the various trade-offs for that, but I don't want to summarize that now. So that's all. Well, that sounds like a great one. Does it? Do you guys want me to talk about it? No, I just meant the whole thing. Oh. Everything you said was awesome. Thank you. Oh, wow. Thank you.
All right, thank you very much. So hopefully we'll see some of that stuff soon in core. So next up, can we hear from privacy and scalability? Somersaults up to the stage or no? All right.
Privacy is related to censorship resistance and fungibility. Censorship resistance because if you want to censor someone, it's probably cheaper for you, instead of preventing them from saying something, to punish them for having said it. And so privacy is the weak link in censorship resistance in a lot of cases. Fungibility means that all money is created equal and it trades at face value. And that's probably necessary to have privacy in the long run if you want your money to have fungibility. There were a whole bunch of people at this round table. I thought that was really cool, because Bitcoin is kind of like a terrible system for privacy in a lot of ways. At the technical layer, but at the social community layer, almost everyone in this community really loves and values privacy, and I like that about that community. And we talked about 3 specific technologies. One is Lightning Network with onion routing attached, and the second is CoinJoin plus confidential transactions. And the third is Zero Cash, which is a protocol that uses those SNARKs that Andrew Polster just mentioned. And they have a lot of different trade-offs on a lot of different axes between the 3 of them. And we talked about how one measures or evaluates privacy. And most of the methods of measuring it or ascribing a metric to it we rejected is not really useful for various reasons. But the one that we thought was potentially useful was the qualitative practice of creating a set of user stories which show if there's a person who is like this and they were trying to use it like that, then would the technology betray them or not? We agreed that privacy is more of a property of groups than of an individual, and so it's really important that privacy technology be ubiquitous and be like the default setting and things like that if it's going to do any good. Somebody mentioned that when they're in their Bitcoin company, when they're talking to potential customers about privacy features, that the customers that respond the most positively to that are banks, because the banks need privacy from their competitors or from other parties. I like that detail because we often conceive of privacy in social terms as sort of like oppressed groups versus oppressor groups or things like that, but a lot of people have a need for privacy as a feature which is a lot more business oriented. Finally, we said that we hadn't really solved any of these problems. We weren't able to agree on which technology or a combination of technologies would help the most with privacy, censorship resistance, and fungibility. And we said that although the problem of privacy in a public decentralized ledger is a really, really difficult problem, that this community is full of really smart people who really care very strongly about that, and so we're not going to give up. That's all.
All right, thank you very much, Zuko. Last but not least, can we have Ethan up to talk about potential for SHA-3-like contest processes for Bitcoin?
So our group discussed potential for SHA-3-like contests for Bitcoin. So SHA-3, for those who don't know, or the SHA-3 contest, was a contest held by the US government to select a new secure hash standard. And the way in which they went about this contest is they had 3 stages. First, they had a bunch of workshops to think about what the requirements are for this new hash function, what it should do, what it should be strong against, what speed trade-offs should be. Once they had done that, they published a set of requirements and then opened the field up to various people to propose hash functions. Once they had gotten the initial proposals in, everyone evaluated them. So different teams attacked other teams' hash functions, and it sort of created this nice arena where you want your hash function to do well, so you find problems in the other people's hash functions. And it was exceptionally productive for the cryptography community. A lot of new ideas came out of this. People, because it happened over a long period of time, people were able to set like long-term research agendas. For example, it started in 2004 and it continued to 2011 when they selected Keccak as the SHA-3 standard. So we discussed whether this would offer a value to Bitcoin, and one of the notions was that this could offer value in the sense of producing legitimacy. So having this nice discussion and having a lot of like reasons in a very like formal, well thought out, logical manner could help these discussions and help everyone just understand stuff. But it could also drive the technology. So one of the questions was, well, with the SHA-3, there was a committee which selected who should be which hash function should win. And this might be contentious in Bitcoin. And so there was some question of, well, is this useful for solving contentious issues? And there was a bit of discussion around that. I'm not sure that we resolved it one way or the other. But one thing that we generally seemed to agree with was that it would definitely be useful for non-contentious issues. And just because something is not contentious doesn't mean it can't like really harm Bitcoin. So we tried to think of what are some issues that could really help Bitcoin and could prevent a lot of problems before they arose that would be good for this contest. One of those we thought of was the peer-to-peer network, because you can run different peer-to-peer networks and relay networks without causing any sort of fork. It's independent of how the blockchain, of these blockchain decisions. That might be a good non-contentious issue, and that approaching non-contentious issues first could be a good way to move to contentious issues later once everyone has seen that the process works and is fair and we get people involved in it. And that potentially having it on a longer time scale of a few years to 10 years allows people to develop technologies that wouldn't have immediate applications, but could have applications long term. A lot of academics, it takes them a while to steer the ship. They have projects they need to finish before they start new projects. And then people see those projects and build something on it. So having a longer term time frame might build confidence and also get sort of like deeper, longer term research projects involved. Let's see. I think that's about everything. We also discussed that SHA-3 was a government project, so it had a lot of government resources. But recently, the crypto community in Caesar engaged in one of these contests, I believe on a shorter time scale, outside of government. So it's certainly, you don't need to be a government to do this. And there was much discussion over funding this and organizing this and who would do that. I say for myself personally, I was not in academia during SHA-3, but I thought SHA-3 was great, so I participated in it. And that sort of arena of attacking things and publishing them actually is one of the reasons why I'm in academia. So I think contests like this can draw people that are non-academics to participate. And SHA-3 was very much also built around a mailing list where a lot of the discussions happened, and then they had workshops which kind of incentivized people to develop things, post the initial results on the mailing list, and then develop a formal paper that really like spells it out and communicates it deeply to the community. I believe that's all we talked about.
All right, thank you very much, Ethan. You're good. So next up, we're going to be having a fireside chat with Elizabeth Stark and Gabriella Coleman, also known as Biella. While we are getting the stage somewhat set up, I just wanted to ask who in their sessions today, in the roundtables that they partook in, felt like they learned something new or something really interesting? Show of hands. That's pretty cool. And who in the summary session feels like they also learned something new or interesting? All right, so I think that this is pretty great. So just round of applause for everybody, because this was really content that you produced here. This is something that was the hard work I said this morning was going to be in making these sessions happen, and the hat trick will be doing it tomorrow. And a mic for you.
Yeah, thank you. Hi, everybody. First off, I want to thank everybody for an amazing first day. I know it's not over yet, but we're extremely lucky to have Professor Gabriella Coleman with us. She's an old friend of mine, and she has been studying free and open source software, communities, hacker culture, and anonymous for a decade and a half now. She's the world's leading anthropologist in this space. She's a professor over at McGill. She has a fancy title. I was just looking it up. And before that, she was a professor at NYU. She's the author of several books, including Coding Freedom and Hoaxer, Whistleblower, Spy, The Many Faces of Anonymous. And we're really excited to have her insights here on her work and scaling open source software communities. So we're going to changed up the format a little bit. I will be accepting questions via IRC and Twitter. If you're on Twitter and if you're watching the live stream, hashtag scaling Bitcoin on IRC, ask the question, just mention it's a question for the speaker. Eric, where's Eric Martindale? He will be finding those and then collecting them, and then I will ask Biela. So I'm going to start off with a question. So Biela, you come from the field of anthropology. You've studied communities and how they scale up. But normally we think of anthropologists as those who study native communities or cultures kind of internationally around the world. How did you choose free and open source software and hacker culture? Like, how did that come to be?
Right. So first of all, thanks for having me here. I don't know too much about the Bitcoin community, but it is fascinating. And I've just been learning a little bit about it before coming here. So again, thanks for inviting me here. So I was a very traditional anthropologist. I went to graduate school to study religious healing in Guyana, South America. You couldn't really get more traditional than that. But I had a side interest in patents and medicine. I followed the politics of patents in the global South quite closely. And so one of my friends who was part of the world of free software pulled me apart one day and said, well, if you're interested in alternatives, you have to learn about this thing called the copyleft. And I was really blown away that a bunch of engineers had reinvented the law, that the copyleft was powering software that was, powering the internet. And that's kind of when I jumped in. And I really had no intention in studying, hacker community or free software community. But there's a lot of cultural dynamics in play, from the kind of prevalence of humor to the ways in which people organize themselves into large, complex projects such as Linux or Debian or Bitcoin. So that's when I got involved, and it's just history ever since.
So one of your areas of expertise is around communities and how they've been able to scale. And you mentioned earlier you've studied Anonymous and the Debian community, and they've had very different models. Can you tell us a little bit more about how they evolved?
Sure. So in some ways, you couldn't have two more different geek hacker communities than Anonymous, the kind of countercultural protest movement that probably you've all heard about in some respects, and the Debian project, the free software project, which is now over 20 years old, right? And one of the reasons why they're so distinct is because Anonymous is so committed to the idea that anyone can be anonymous, that there really is very, very little energy put into formal organization. Organization does happen, but it's quite informal. It's norm-based, or it emerges through interaction on chat channels like IRC. Debian, on the other hand, is quite amazing, actually. I mean, one of the things when I jumped into this world to study, there was kind of economists and lawyers and political scientists studying free software. And the way that they would often describe it would be peer-to-peer. They would use terms like adhocracy. It made it seem like things were, totally always self-organized. And there is definitely some level of constant openness and self-organization and adhocracy in free software projects like Debian. But when I kind of jumped in 2000, 2001, 2, 3, 4, 5, which is when I studied them, they were so incredibly well organized as a social institution, and they had really complex forms of governance and voting mechanisms and procedures for adopting new members. And this was kind of another surprise. I was like, oh, I thought all these geeks and hackers just wanted to like code, right? And debate code. Well, they do, but they also were very adept in building a complex social system. And there's many different parts to it. Maybe we could get a little bit into it. But yeah, while Debian is, very well-oiled institutional machine, Anonymous is, more like a hydra that really resists any forms of governance.
So we're here today in Montreal. This is an event that has focused on the issue of scalability research, but I've been on the planning committee, and this kind of came together very quickly. to say the least. A lot of us were, had many sleepless nights. Pindar's laughing over here. What is your experience with other communities as to when there's a recognition that there's a moment that people need to come together and something needs to happen?
So it seems like with a lot of open source projects, there's either a moment where they hit a core number of developers, 200, 250, 300, where they feel like they actually have to meet in person. And this usually translates into small developer meetings or annual developer meetings. And this is the case for Tor. Tor is about to have their project developer meeting in Berlin. Linux, Debian, Apache, it can go on and on and on. And I would say these face-to-face meetings are incredibly important. And I was actually kind of surprised to hear that this was one of the first kind of meetings where developers have come together, right? And it's just often necessary to provide some sort of cohesion and an ability to kind of reproduce in the future with or without crisis, right? I mean, it's just kind of, looks like there was a question.
Oh, we're doing questions via IRC and
Okay.
Twitter. So if you want to IRC it, we'll get them in there.
So it's pretty rare to have a community that doesn't hit a certain number of people. That kind of forces them to meet. And those that don't meet often crumble and fall away. And one really good example of this is Indie Media. Who here has heard of Indie Media? Okay, so some people. It was started by a bunch of hackers who were really inspired by free software in 1999 during the World Trade Organization protests in Seattle. They just wanted to make sure that people had an outlet for broadcasting media independent of corporate media. It was a phenomenal success. Within a couple of years, there was over 200 indie medias around the world. There was a global network, there were regional ones. It was incredibly robust. It was a very technical project and a very political project. And in some ways, a couple of years after they started, it was perfect for them to kind of have a conference. And they never did for reasons I won't go into. And that was one reason I think the project, failed. I think it's a bit more complicated than that. So that's one really important element. The other element too is that most open source projects do have moments of crisis when there's growth or differing opinions on how to handle core issues or governance. And they usually provide a moment for people to kind of refigure things like governance or face-to-face meetings. And, many projects do kind of respond to it in very productive ways, although I think it often feels very treacherous.
Brian Bishop asks on IRC, how large are the Tor developer face-to-face meetings?
I haven't been to one, so I
Peter
don't
Todd?
entirely
I
know.
You're friends with them, Peter. Are you around? Do you know?
But I think
it's like what? But do you know how large the developer
the
meetings
number
are?
of developers.
Like how many devs? Okay.
Yeah, so it's pretty small. And then something like Debian is 400 to 500 people. And they have a 2-week meeting. The first week is like a work camp where you get to work on projects. And that's quite fun and productive too, because sometimes as a volunteer, you're stretched thin for time. But for this week, you can really do some sprints. And then the second week is more like talks and a constant party. And the bonding that occurs, it's just kind of unbelievable. I went to the Debian Developer Conference for many years in a row, and then I didn't go for 4 years because of moving, Anonymous, and then I went back last year for the first time in 4 years, and this is a little emotional, but I almost started to cry just seeing everyone. And it's kind of amazing to see Debian developers, some of whom have been involved for 15 out of those 20 years, right? They're really kind of growing old together as a community. And it's really allowed them to weather the storms in a way that I think would be much harder otherwise.
Brian Bishop also asked if there are any Debian developers in the Bitcoin dev community. I don't know if you, Bill, or does anybody in the audience know of any kind of interconnections? Oh, hi. Okay, okay.
You're both a Debian developer.
And a Bitcoin developer.
Okay. Labs, right. And it is a project that can tolerate that quite well, right? It's a large project. There's over 1,000 developers, but probably only half of those are pretty active, and then another half really are carrying the project, right?
So speaking of which, Rusty on IRC asks, what time period did it take similar open source projects to reach organizational stability?
So 1999 was a really important year for Debian, and it was founded in 1993, right? 6-7 years. And that year was a big crisis moment. And it was a crisis moment because Debian was quite popular, and a lot of people wanted to become part of Debian. And to become part of Debian, you just sort of had to work and contribute, and then someone who already was in the project would vet you, and then you'd get access to the system. But then people who'd been around for a long time felt like, you know, the quality of some people and the commitment to free software, because it is a very kind of free software project. It's very oriented that way. They felt like people coming in didn't have the same outlook or values, nor did they necessarily have the same kind of, you know, technical chops / knowledge of Debian. So they basically stopped some people who were core members who would integrate new members into the project by getting their PGP key, verifying them. Ooh, that reminds me, I'll tell you something important about PGP and Debian. They basically stopped admitting any new person and said, no more. Project, you go figure it out. You figure out what we're going to do to resolve this problem of kind of like quality control. It took Debian 1 year to figure out a process. And what they came up with was the Debian new maintainer process. And basically, you know, it's evolved over the years, but basically what it is that if you want to become a Debian developer, you need to find a kind of advocate, and then you need to go through a testing process. And the testing process tests you on everything from free software philosophy and history to legal knowledge to knowledge about Debian policy and just how Debian technically works. And you're linked up with a person who does the testing. And the person who does the testing has some flexibility. So I'll never forget one of my friends once wanted to become part of Debian, and he got like this 16-year-old German Debian developer who gave him something like 50 questions to answer. And he was just like, oh my God, that's just way too many. And he like put it aside for a year and came back later. But you have to go through that. And basically everyone who does go through it, you know, is usually admitted. It's a way to kind of, you know, ensure that, first of all, you have the right background knowledge and you're truly committed. It's a little bit of friction to enter the project, but once you do, you get your email, you know, you feel proud that you went through it. And actually, another thing that Debian requires is that once you become official Debian developer, you have to have another Debian developer sign your PGP key in person as well.
A rite of passage.
It is a total rite of passage, and it's as important kind of ritually as it is just like technically, right? You know, you've earned it in some ways. And again, it does allow or ensure that there's some kind of pedagogy, so you know how Debian works, because Debian is actually pretty complicated. And it's not that every open source project needs to become as complicated as they are. But if you're going to have over 1,000 developers, well, you have to have some policies, and then you have to ensure that there's a way for new members to learn those policies.
So Kobe on IRC asks, from an anthropologist perspective, what traits have identified open source communities that have been good at making decisions? This gets in a little bit to what we discussed, but.
And just very briefly, that wasn't the only crisis moment in Debian. It just was one having to do with governance, and there have been many others, and they've refined and retooled their kind of modes of governance many times since. Well, the good thing is there is thankfully no one single model that works for different open source projects, and that's actually a really good thing. Because, for example, you know, certain projects have benevolent dictators, right? And usually those projects with that type of governance, the benevolent dictator is the founder, right? And so something like Bitcoin, where the founder is this, you know, anonymous, mysterious, mythical character, right? You don't have that type of person. And I've never really heard of a successful project where you had a founder that came many years after the fact, right? But benevolent dictators can kind of work to some degree if there's a founder, but usually that style of governance is matched with other modes of governance. So with Linux, for example, the Linux Foundation really matters quite a bit. People are hired, and there's also other core developers who kind of control little fiefdoms. I do think, most open source projects, even Debian, which really relies on governance, they don't like to make technical decisions through voting. They still really believe in consensus. And there is a technical committee that, for example, is constituted to help resolve any issue that can't be resolved through community debate. And then there's other projects which, they limit the kind of core number of developers to a much smaller number, to 10 to 12. So they're kind of de facto technical committee. So I do think, maybe one thing is that it's still really important to ensure that that commitment to consensus making still exists, even if you have modes of governance in place. That's one thing that, Geeks and Hackers are obviously very committed to.
So Digitized Currency Now on Twitter asks about how can you detox a community? So you've also worked with Anonymous substantially, and clearly there has been a lot of trolling involved. Now you may have had other experiences with FOSS communities, but are there strategies that have worked in your experience, and is this something to learn from?
Yeah, I mean, again, Anonymous is such a weird beast because they're like, detox? We like drugs. We like craziness, They're kind of an entity that breeds controversy and thrives off controversy. And so, again, there's...
Has there ever been a gathering in person? No, right? Because everyone's just trying to be...
No, I mean, because it's a community that is into law breaking, it's not so wise to meet. But people who have been arrested, such as members of LulzSec, if you heard of LulzSec, all know each other, and we were all at the Chaos Computer Club camp, actually, in Germany just now. So once you've been demasked, you do meet. But it is a weird community where, because of the illegal nature of a lot of their activity. But in terms of, again, Debian, there was another crisis in 2005 where a number of very important technical members got together in Vancouver. And that was not unusual because they often did get together, but they basically came up with a decision to get rid of an architecture, I believe. And then they posted about it on a mailing list. And instead of writing it as a proposal, it was kind of presented as a decision. And the project went berserk. I mean, completely berserk. In one day there was like 900 messages. It was this like, what are you doing? You're making backroom deals. The cabal is making backroom deals behind everyone's back. This is not allowed. And I wondered, is the community going to survive this? Because everyone was so mad. And basically the members of the members who had gone to Vancouver in this meeting did have to explain themselves over and over again. No, it's a proposal, it's a proposal, it's a proposal, it's a proposal. Oh, it became a proposal. You see what I'm saying? And so they really had to defer to that mechanism of ensuring that there was an open debate about any technical decision. That's really important. And it's hard sometimes, again, with so many members, right? But nevertheless, you kind of have to put it out there. And then again, there's a technical committee who can arbiter in any difficult situation. And I should look up the number, but I think the technical committee has only made final decisions a handful of times in the last, 15 years.
So you've studied FOSS communities, and typically we've only seen numbers of about, say, a few % of, say, female contributors, and there hasn't necessarily been as diverse of a team contributing, although hopefully it's getting a little bit better. It's substantially lower than that of in programming and tech more generally. What have your observations been around that and FOSS communities? I know that's something we here in the Bitcoin community care about.
So this is something I care quite a bit about. I'm actually part of an organization called the National Council for Women in Information Technology, which is all about getting more diversity in computing. And I'm kind of the representative from the open source and hacker world. And, first, one thing to say is that it's a general systemic problem. I don't think like open source or the hacker world, is in any way unusual. The peak number of female undergraduates in computer science came in 1984, you know, and 2000.
It's gone down ever since.
Yeah, it's gone down ever since. This last year was record-breaking in terms of an exodus of women in the tech sector in Silicon Valley. There's a lot going on. So there's no like simple thing to say. I've actually often think that open source, certain projects, Debian, Python is another one, have been really remarkable in terms of trying to do things about diversity. So Debian founded Debian Women in 2005. Python had a diversity list and have also really have been so aware of trying to increase diversity. I think the important thing...
I think Node.js has done a lot of interesting efforts as well on that front.
Exactly. And the important thing is to recognize in the first place that there's a problem, you know, and that it's not going to solve it, itself on its own. And so one has to be proactive in order to fix the problem. And that, you know, the successes have come from being proactive.
Jeremy Rubin on IRC asks, what are big risks other communities have taken and how have they gone? Is conservatism good? How does this change given that Bitcoin is anti-risk by design? Yay, Jeremy.
Yeah, I mean, that's a really good question. And there's a way in which, you know, being incredibly risky is often not a good idea insofar as, you know, communities require stability and tradition, you know, to grow over time. But, you know, no community evades crisis. They just tend to be different ones, right? So for Debian, they're very internal focused. Tor, on the other hand, a lot of their crises have to do with the fact that their public image is often under threat because, whoa, you could use Tor for child porn. You know what I mean? And you know what they did, which they should have done a couple years ago? They hired a kind of publicist communications person, right? Because there was a lot of crises over their public image. And so they did, you know, the risk-averse thing, which was hire a kind of community or communications person, right? So I'm not coming up with any good ones in terms of like super risky ones that I can think of. But I do think that often with open source projects, you know, everything first emerges in a very ad hoc way. And who likes rules and who likes red tape, right? But at some point you need to kind of organize things, and you can do it in a way that does not create an organization with massive red tape if one is smart about it.
So Wiz on IRC is curious about, in Debian, have there been forks? And if so, how has the community dealt with this? And where did they come from?
So, I mean, Debian, I think that there's, you know, like dozens and dozens of derivatives, and forking is usually not a problem. But it was a problem once with Ubuntu. And that's because Mark Shuttleworth came along one time, and he decided he wanted to create, you know, new distribution, and he came to the Debian developer meeting, and then he hired a bunch of the core Debian developers who eventually had no time to work on Debian, and there wasn't good kind of communication between projects, and Ubuntu wasn't sending their kind of patches in a, you know, straightforward way to Debian. You see what I'm saying? So there was a kind of moment where there was this fork called Ubuntu who relied on Debian. There was a lot of bad blood between the two projects for years. I would say that era is over now. And why is it over? Well, it has everything to do with the fact that Mark Shuttleworth would go to the Debian Developer Conference every year where things were tense. Certain core developers who care really about Debian and Ubuntu mediated between the two projects. And now there's much better kind of exchange of technical information. It took years though, right? And so that's another thing to maybe remember is that, you know, if there's risk or crisis, sometimes the solution won't come in 6 months or a year, but a couple years to hammer things out.
Leviathan on Twitter asks if your communities that you've studied have dealt with external actors attempting to subvert the internal ethos or the community ethos.
Oh, That's a good question. I mean, this is slightly different, but I think a good example. So Debian had a Nazi who was a Debian developer, Walter. And he didn't, post his Nazi stuff on the Debian lists. But if you went to his webpage and followed him, you knew that the guy was a racist and a Nazi. And people were like, do we do something about this? And people, Debian is a very free speech project, and people felt like, well, so long as he doesn't bring those values into this project, we're not going to do anything about it. And that, kind of norm was the case until he came to a face-to-face meeting. And I won't go into the details, but he did some pretty inappropriate things. And then the list masters and the FTP masters just booted him out. And that was kind of an interesting moment. I mean, slightly different because I don't think he ever really threatened the technical integrity of the project. But Debian is configured in such a way where that's really hard to do. That's really, really hard to do. Because, for example, there's a Debian project leader that's voted in every year, but they have no technical power whatsoever. It's a way to it's a person who oversees the project, what's going on. They help mediate, actually, between different factions in the project, right? They're also a nice interface between the public and the project. But they're voted, and they can do it for a couple years, but it's rare to have, and actually I think that there's a limit too. So it's very hard for one person to ever kind of control things because power is more evenly distributed.
Madars and IRC asks if you think the Debian model is one other FOSS projects should strive for example, Bitcoin. I know you've mentioned many different models across different spectrums.
Yeah, I think Debian and Apache are both really good models. Apache is a little bit smaller, and I think those with voting rights tend to be a smaller kind of group of people, but nevertheless they have an interesting governance system, and they might be interesting to look at because they're just slightly smaller than something like Debian. But Debian does have some really good elements because, for example, for things like questions of governance or legal matters, anyone can bring forward a general resolution and the whole project votes. But again, it's not for technical matters. It's like, how do we run this project? And that's open to everyone. And they've managed to make it work for over 20 years.
In the Debian community, so here in the Bitcoin community, we have a lot of different stakeholders, and almost all of them, I'd say, are present today. You have investors that have invested in this space. You have startups that are building technology on top of the protocol. You have the mining community. You have the core developer community. You have designers. Is there an analogy in Debian or otherwise to the many different stakeholders at hand?
I mean, I think Linux has more stakeholders, right? I mean, Debian is one distribution, but the kernel, which is in so many distributions, right? And so looking to how they've managed things, because they've worked with big companies, I think is another really good model to turn to. And so turning to people who run either the Linux Foundation today or turning to someone like Linus, who's been there the whole time, right? And who can sort of say, yeah, this is how and when we've changed things. This is when we really decided to work with corporations. This is when we decided to establish a nonprofit as well, right? So that's probably a slightly better model for certain aspects of the Bitcoin community than Debian, which is so weirdly just into free software and doesn't, interface too much with other stakeholders.
Follow up from Digital Currency Now on Twitter, asking if you have any known ways for reducing personality conflicts between super smart but diametrically opposed individuals in the communities in which you've worked.
That's like the perennial problem, right? And this is where I go again, meeting in person is so important. I mean, in my book, I even have a quote from, some Debian developer who said something like, I really thought this other person was an asshole until I met him, and I wanted to quit the project, but finally when we got together, we could work through these things, right? And this is where if you only have the online interaction where you don't, know the person or you can't think of the person, you don't have any kind of other relations except that intense interchange, that can go south really quickly. And the face-to-face stuff won't necessarily solve all the problems, but it can definitely go far away in mitigating that very problem. Now, this is a kind of constant problem with lots of communities. I know this is a big problem in Wikipedia, in fact. And
Wikipedians here, SJ, others?
Yeah.
Some? Okay. Probably somewhere outside.
And Wikimedia is working on ways to deal with this very problem as well.
Jay Timon on IRC asks if you know of any other FOSS communities where there are many different implementations and projects, but one single common specification. In the case of Bitcoin, the rules of consensus.
Wait.
As in, basically, do you know of any communities where it's so dispersed and there are a lot of different implementations, but everyone's united around this common ground?
Okay.
Is that
like
Jorge,
one core
is that an accurate,
technical aspect?
Description of your question, Jorge? You're somewhere here? Okay.
Right. Sadly, I don't know because of Anonymous, which took my life for 3 years, and there's no agreement on anything except anti-celebrity. That's
you could argue there is a single common specification, being an anonymity and anonymous, kind of the broad-based.
Well, there is, but it's not a technical issue.
Sure.
But I think it is worth exploring which communities are like that, because that again could be a really good model to turn to. Absolutely.
Brian Bishop asks, what other good anthropologists are working in open source software, free software, cypherpunks, or even Bitcoin?
Okay. So there's not an anthropologist working on Bitcoin. Otherwise, they'd probably be here. If they weren't, then they're not a good anthropologist.
We're looking for volunteers.
I know, but there should be. I'm just I actually think Bitcoin and Tor are the two most interesting open source projects right now to study from an anthropological perspective. And yeah. But it's, when an anthropologist works on something like Bitcoin, it takes over your life. You're spending 15 hours a week on the project, and I've just come off a huge one in writing a book. So I'm a little hesitant, but I think it is really, really important. For other people who've written some stuff about it, Chris Kelty has written about free software communities. He has a book called 2 Bits, The Political and Cultural Significance of Free Software. And then there is a kind of bunch of articles, more specific articles about organization and stuff like that. So if you poke around, you can find them. But there's no one actively studying Bitcoin or Tor right now, anthropologically.
Interestingly, a lot of computer scientists are studying both of those fields, and we need to recruit the anthropologists as well. Closing question. What is your vision? So you've studied these communities for 15 years. You've been immersed in them. You've really been embedded. You've been a part of them. Where do you see things headed in terms of scaling up communities, getting more contributors to FOSS projects, ensuring that people, can get along and can be collaborative?
So, it's first of all an open question whether communities open source communities can survive a temporality past 15, 20 years. You know what I mean? Or whether that's just their life cycle.
Luckily, we've only had apparently 6.67.
Yeah, so you've got another 7 years to go. No. But I do actually think it is possible, and we already have enough projects from Wikipedia, which is not a technical project, but it's very actually similar in terms of its problems and ethos and modes of collaboration to Debian, to Apache. I think one of the tough things is finding that right balance between being able to get a core number of developers who are basically paid to do what they do, and then continue to kind of harness the power of volunteers and make them feel like they have a stake in the future of the project, because if they feel like they don't have a stake in the future of the project, then they're kind of going to go away. And so that's incredibly important. But in terms of, real robust kind of online communities, it's the free software projects in some ways that have lasted. Usenet's not around, right? Who knows if Reddit will be around? But I do think Debian will be here another 10 years, and the kernel and Wikipedia and hopefully Bitcoin as well.
Thank you so much, Gabriela. By the way, at Biella on Twitter, if you want to find her and follow her, at Biella. All right, Pindar for closing.
Yeah, just want to, can we please again put it together for Gabriela and Elizabeth for having that great fireside chat. Okay, this is the end of day one. We've got a public service announcement. Again, the most important thing probably today, it's a long day. The room is still full, which is excellent. We have a brief 8-minute walk to the reception at Newtown at 1476 Rue Crescent. Public service announcement for tomorrow is, as you know, thank you very much for your time management today. Tomorrow will begin at 9 a.m. As you know, we have several sessions, starting with community communication channels, followed by payment channels in Layer 2, mining and network costs, and block size research. And then we have a slight change. We have an invited talk by Nicholas Negroponte just after lunch. So just a final reminder that the Code of Conduct also applies to the social. So although you have a great time at this evening at Newton, please do respect the rules of the conference. Thank you very much, and see you at the reception.